Okay.
Okay, welcome to, hi, I need some data. Let me introduce Leslie McFarlin, and then I'm just going to be quiet and let you go from here. And just a reminder to people, put your questions in the Q&A section, and I will moderate them at the end. So thank you, and go for it.
Thank you. Fantastic. Thanks, Debbie. Okay, so my name's Leslie. I'm the principal UX architect at Wheels. I've been there for 5 years, and the reason I'm giving this presentation, or maybe the reason why I'm qualified maybe to give it, is because my primary focus there is doing UX research, but I also blend UX research with data analytics. So what I'm trying to do here is give a talk that makes the case for doing that and sort of teaches you some of the basics to get on that path. So to get started, more in detail about what this is about. So I think it's learning from someone who set out to partner with data analysts, but then wound up becoming analytics team for her UX team. And so I want to share some perspectives and some knowledge that will hopefully help you avoid crashing headfirst into a few walls like I did. But then I also want to present an example that applies analytics methods to data that isn't typically thought of as being for analytics. But probably above all, I want everyone to understand that this is not me telling you that you have to follow exactly what I present. This is just my journey. So just listen, see if anything here is applicable for you. And if it is, if it makes sense, then try it out. So in specific, why am I doing this presentation? Well, we all see companies are putting machine learning and AI into all of their products. And the success of these products depends in large part on the quality of data used to define them and maintain their functionality. And so you may start to see, like I have in my organization, a requirement for UX to become better with data in order to do a few different things. And those things are understanding the intricacies of the features, the data-driven features, ensuring the internal artifacts can keep up with the increased speed of changes having such products can bring, and then providing insights that help other teams also keep up with the faster pace of change. So, you know, for anybody finding themselves pulled in a similar direction, hopefully this presentation will offer you something useful. So I'll go a little bit into my journey, and this image is pretty apt. It generally goes in one direction, but it is kind of all over the place. So to clarify how it started, this goes all the way back to 2021. I received some CSV files for a yearly usability survey along with the previous year's report, and I was told to do something useful with the data. I had 2 months. Okay, 2 months is good, 2 months is fine, I can roll with that. So I took a look at the data, and long story short, we had questions combining unrelated concepts, and I had no understanding of the survey's latent factor structure. So I don't even really know if it was measuring what it was claiming to measure, but I had to run with it. Then I also needed to analyze hundreds of open-ended responses to questions and perform statistical analyses on over 3,000 data points with only Excel. If you know Excel, data point analysis can be done. Analyzing open-ended responses can be a little bit tricky. Happily, with 2 months, I figured everything out. So the success of the analysis and the report kind of set me on my current path, and everything looked fantastic to everyone else. But what people didn't see, both on my team and other teams, though, was this mad rush to skill up in 2 months so I could actually create something insightful. To give you an example, I was up at 5 a.m. practically every morning building on my Python skills so I could actually do deeper analysis of quantitative and qualitative data, but specifically the qualitative data. And to follow on to that, I was spending most of my evenings on sites like Hugging Face and edX, learning how to select algorithms and figuring out how to perform sentiment analysis and topic modeling based on the features of my qualitative data. But with all of that hidden, it really just seemed that all I had to do was build credibility, right? You know, credibility with product, credibility with IT, with the data teams. So I can't teach you all of the technical knowledge in one presentation, but what I can do is hopefully get you set on the path to learning some of the basics and building credibility. So if you find yourself in a situation like mine, you can survive. So building credibility. When I'm talking about building credibility, particularly with data teams, I think really it's just acting like a good teammate, but I want to break this into 3 parts just to, make it a little bit clearer. And those parts are understanding perspectives, learning language, and crafting scenarios. So by understanding perspectives, it's really looking at the question, can you empathize with challenges the data analyst might face when dealing with your requests? Analysts often are busy with multiple fires. Everybody wants data. Everybody's request for data is important, and everybody else has to take a back seat to them. So lots of fires. But also, data is sometimes poorly curated. So you may think it's a simple request, and it's actually not that simple. Learning language. So this is how well can you communicate with data analysts? The data analyst is going to hear your request and say, okay, how hard do I have to work just to understand what you want, understand what you're trying to do? And then once they have that knocked out, they're going to wonder, do you really need them to do the work, or can they give you the data and turn you loose? And then finally, crafting scenarios. So the question being, what is the ultimate end of this work? Because when you're doing any sort of research, right, you want to have like this big picture of what you're going after. So really, that's something that you want to be able to clearly convey. But data analysts are also going to wonder, is there something of value in the outcome for them as well? So will this be something that's reusable? They can use it as a building block for future work, or is it kind of a one-off? For some teams, that actually may have an impact on whether they help you or how quickly they help you. But what I want to do now is focus on language, because I think language is really what makes everything possible when building credibility. Because language is, it's really a signal to others about who or what we are. People will use language as an indicator of similarity or relatedness, and they sometimes use it to judge your knowledge. So when dealing with data teams, if you know some of the language of data, then you have an advantage. It's easier to understand perspectives. It's easier for others to understand what you're trying to do, why, and sometimes even how you're trying to do it. And then others can determine how much help, if any, that they need to give you. So what I want to do from this point is go forward with learning some of the most basic language of data, just to help you build knowledge of data features. So things like structure, content, level, and knowledge of handling data, so types of analytics and methods. And I will lead in with this. You probably have heard all of these terms, but something I've noticed in the past with people that I work with and other UXers that I know is they have heard all the terms, but they don't always put them all together. So what I'm trying to do is give everything in one shot in hopefully what's a package that, makes you realize the connections if you haven't already realized them. So to that end, let's start with structure. Structure is pretty simple. Your data is either structured or unstructured. So structured data is data that's organized according to some sort of predefined model, think tables or files. It's clearly defined. It can be easily searched via, man or machine. But unstructured data doesn't have a predefined model. So, it can have its own internal structure. It may be in a native format, and it may most likely require additional processing before being useful and understandable. So the structure of data will impact access. So let me give you an example of that. Let's say you've already got the hurdle of someone has to get data for you, but now imagine that they have to process the data for you, or if they can't process the data for you, they have to reach out to another team who can process the data for you. So you may run into a situation where it's kind of like, okay, I can't rely on this team to process the data, but there's nobody else available to process the data. I have to figure it out on my own, or I'm just going to have to put what I want to do on a back seat until somebody can come along and process it for me. So this is, potentially a struggle you could run into with that. And then data content. So this is something, quantitative or qualitative. We already know this. Quantitative is numeric data, describes quantity. Qualitative data describes qualities, and it's things like text, speech, video data. You can quantify certain aspects of qualitative data, and data content is something you have to consider when you start getting into discussions of what question or questions you're trying to answer and what you think you'll get from the data. And then there's level, and that actually digs in, I think, a bit further to content. And there are 4 levels of data. So nominal, ordinal, interval, and ratio. Nominal is categorical data that lacks hierarchy. Ordinal is categorical data with hierarchy. Interval is numeric data without a 0 point, but it does have equal intervals or can be assumed to have equal intervals. And then ratio data is numeric data with a 0 point and can be assumed to have equal intervals. So this is another thing that will also impact your data handling in specific understanding why a data analyst or you should use a particular technique. So now I want to move on to types of analytics, and we'll start with descriptive analytics. This is really the backbone of data analytics in general because it describes something you're interested in, right? It answers the question of what happened. And so some examples that you might already be familiar with are, measures of central tendency, so mean, median, mode. Then there's more advanced things like topic modeling, clustering, which I will talk about in this presentation, and then network graphs. Then there's diagnostic analytics. So these are methods that help you identify phenomena. So that would be something like hypothesis testing, anomaly detection, correlation, data mining. And then predictive analytics. So if you've got a large amount of data and you want to make predictions about future events, you would use predictive analytics methods. So these are regressions, time series analyses, decision trees, random forests, neural networks. And then finally, prescriptive analytics. So this can be based on the output of one or more methods, but prescriptive analytics is what you would use when you want to create recommendations on something someone should do next or on how to resolve issues. So yes, you can use multiple methods from across descriptive, diagnostic, and predictive methods, but you can also use things like simulations and optimizations. So this is the last pairing of language we need to know, but this comes down to unsupervised versus supervised methods. So unsupervised methods are looking at features and patterns in a data to identify interesting structures for further investigation. They're not really doing predictions. So as such, you don't have to have something like ground truth label. And these are things, again, like clustering, principal component analysis, multiple correspondence analysis. And compare that to supervised methods. These are the ones where you would be doing predicting. So they do require ground truth details about data that's received. And this can be things like k-nearest neighbors, regressions, classification models, time series. All right. So next, now, I've introduced the perspective I took. I've talked through some very basic terminology. I want to walk you through a very pared down example of applying data analytics methods to help build personas. And in particular, I will focus on fleet driver personas because historically, this is a very hard group for my team to interact with. And the work done here has helped us better understand the drivers so we could actually start kicking off persona research projects. So while it doesn't use analytics like we think of from websites and mobile app use, it shows the wider applicability of analytics methods, in particular analytics methods in service of UX. So as part of this section, I will be talking about specific methods, algorithms, and metrics, but I'm doing this because I want you to hear the terminology so you have an idea on where to start looking if you want to educate yourself further on this kind of work. And also the methods I will focus on here, clustering in particular, are among the easier ones to understand. So to set the scenario for you, I walked into a meeting and like the title on this slide says, surprise, there's data I can use. So basically I find out in a meeting that there's customer service satisfaction data existing in another team's silo, but I have no access to the data. In fact, nobody on my team, including me, even knew the data existed or the survey existed until someone from marketing came to our team meeting to tell us about their Qualtrics analysis. So I find out the survey is run twice a year, which is fantastic. It's not, live streaming data like you might get otherwise, but coming in twice a year, it's relatively fresh. We can deal with that. But we have these potentially valuable insights not being leveraged for design decisions, but without access, I can't connect that satisfaction data to opportunities for UX improvements. So right out of the gate, my challenge is, how do I get access to this data? Not successfully to start. I was ignored for 3 weeks by someone who did have access, and then she went on maternity leave. So I eventually found a director who had access to the data, who was kind enough to send me a bunch of CSV files for 2 user groups that took the survey. One was fleet leadership, so the people who are in charge of all the drivers, but then the fleet drivers. And again, the fleet drivers are the ones that I'll be talking about mainly in this portion. So I have the data, now what? Well, let me at very high level lay out to you what happened. So our objective was to understand the survey data and how it links to our knowledge about the state of UX, because we want to answer 2 questions. Can this help us argue for improvements? And can we find UX research opportunities? So with that out of the way, we have to figure out what's our approach. Well, we want to identify any useful groupings in the data. And then once we've uncovered that, what we want to do is share back anything new we generate, because being a good teammate, you don't sit on your data, you share what you learn. So the outcome ultimately is we did reveal groupings of survey respondents based on the response sets that confirmed existing knowledge, but also offered new insights. Interestingly, we also, through some follow-up analyses, confirmed suspicions about service linchpins as well. So what I want to do next is talk about approach, building the analysis. So let's start with what data did we have? Well, we had contact reasons and methods as binary data. So you either used a method, you either had a reason, or you didn't. So yes or no. This was categorical. And then we had satisfaction ratings on a scale of 0 to 10. So we can argue its ratio. But then we had open-ended responses, qualitative data. Well, what can we do with this? Well, since we need groups, clustering was a pretty good candidate. We had hierarchical clustering for the categorical data. We had k-means for ratings, but then we did ensemble clustering for final clusters. The topic modeling and sentiment analysis, we use that for open-ended responses, but due to concerns from my employer, I won't really be talking about that. They're just afraid I might accidentally mention something that they don't want out in public, so I will focus mostly on clustering. That being said, what can we get from these methods? So from clustering, you can get the groups of respondents based on their response patterns in the surveys. Topic modeling will give you groups of topics, and classification from sentiment analysis will show you positive, negative, or neutral valences for your comments. So you can see from this, you can start tying in the valence of responses to the topics, and then you can start aligning topics with the clusters to understand, okay, what are the concerns? What are the attitudes around those concerns? Things like that. So you're not always just stuck with the clustering. You can do deeper work beyond that. So what does clustering do? And I'm going to try and tread the line with being technical, but not too technical. So bear with me on this. So hierarchical clustering, this really builds a tree of relationships between data points such that similar ones are grouped together over multiple steps. So thinking of our binary contact data, it helped uncover how specific methods and reasons lump together across respondents. So let me give you a little bit more clarity around hierarchical clustering in general. Think of how you might organize sticky notes from user interviews. So at first you just have a bunch of notes up on a wall, and then as you review them, you start to group them thematically. It could be for like pain points, it could be things people like, whatever you think is the best theme. So you might go from 100 sticky notes scattered everywhere into 7 groups of sticky notes, which could have things like people don't like our password recovery flow, they don't like checkout flow, they don't like the request to callback flow. So hopefully that clarifies hierarchical clustering. For the ratings, we did k-means, and k-means basically groups data into clusters based on how close data points are to each other. So we opened with standardizing our ratings variables so we could use them in principal component analysis, PCA, and the PCA helps us distill the ratings questions into more impactful latent features for clustering. So let me clarify that now a little bit more. Standardization kind of ensures the data points are weighted equally. And this is important for PCA because it's an unsupervised method and it's really looking for directions in which variations in the data are the largest. So what you're trying to do is avoid having any one variable have undue influence in PCA. But then PCA itself, as I mentioned, it looks at the most impactful latent features. Really, that's identifying core drivers. So it makes it easier to understand why clusters emerged. But also, because there are a lot of variables, we had, I think, 26 ratings, and 29,000 data points, there can be a little bit of, it can take some time to run the analysis. So PCA can reduce that time constraint. And then finally, ensemble clustering. So ensembling is a very general concept in machine learning and also in data analytics. It just refers to combining the strengths of different methods to create more robust and stable groupings. For ensemble clustering in our study, we used agglomerative clustering to combine the output of the hierarchical clustering and the k-means. So let me dig in a little bit more to that to hopefully clarify things. For ensembling, think of it as building consensus from multiple viewpoints. So imagine you're combining multiple UXers' opinions into one final judgment about some observation. For agglomerative clustering, it kind of matches data in pairwise fashions from the bottom up. So eventually you get to, in some ideal amount of clusters. If that sounds kind of similar to hierarchical clustering, it is, but the difference being is hierarchical clustering gives you a broad theme view. Agglomerative clustering will go into that theme view and say, okay, people are saying they don't like the password recovery flow. What are the different reasons or the different sub-themes we're seeing for them not liking it? So, okay, hopefully that clarified things a little bit. So next is understanding your clusters. So at this point, if you're working with a data analyst, they might ask you, do you want to understand why your clusters broke out the way they did? If you answer yes, and you should always answer yes, or if they already did it on their own, more than likely they're using some sort of supervised machine learning algorithm to build a basic model from your entire data set. So your clustering data set complete with your cluster assignments to build something we call feature importance. So like very generally, think of this as a way to conduct a follow-up analysis on clustering that helps you interpret those results, because clustering tells you that there are patterns that give you these groups, but feature importance explains what the patterns are based on. And this is really what helps us go from sort of like the abstract cluster concept to getting closer to, personas or groups with defined characteristics. So for me, as the person that did this work, to put the technical spin on it, I used a random forest classifier from XGBoost to get the bird's eye view of the feature importance that led to cluster formation. And so all of that actually ties into global differentiators. So the global differentiators, based on feature importance, answer the question of what variables sort participants into clusters. So it's considering your data set as a whole. Then you can dig down into something called local differentiators. This is where we look at something called SHAP values to understand how much each feature, a feature is a variable, contributes to the model placing participants into one cluster versus another. So this is actually at the individual data point. So, if you have Bob, you're asking the question, why is Bob in cluster 0 and not cluster 4? SHAP values can help you answer that. And then finally, there's profiling by cluster. This is something that's going to be very easy to grasp. This is just, you go in and you calculate average or median ratings. You start looking for correlations. Like we looked at correlations between contact reasons, methods, as well as among different ratings questions. And it was really answering a more general question of how does satisfaction or relationships between variables change across clusters. So how does this help our personas? As I mentioned earlier, drivers are very hard to get into research studies. So we used this analysis to gain insights to help guide our persona surveys and interviews, because the last thing we want to do is say, okay, these are actual personas. This is a good start to get to our persona. We have to have that extra work of, persona surveys and interviews to humanize it, because numbers are not very human. They're great, they're insightful, but they're not people. Then we found patterns that people were not seeing before, and we were able to verify those patterns as known client issues with client-facing teams. I have a lot of strong feelings around this, because this was one of those situations where, the client-facing teams were telling product teams that there's issues here, and product teams were like, oh no, that's not an issue. That's really not what's at the root of it. No, that's actually what's at the root of it. That's what they're telling you. And then finally, we can track how driver concerns and needs change over time as the survey, it's run twice a year. So we can start responding to issues sooner, because we'll see them sooner than just them maybe filtering down a year later from somebody's feedback. So things to consider. We're almost done, I promise. There's really one big thing to consider, I think, in light of this presentation, and it's the question of how technical, right? How technical do you want to be? And there are two approaches you can take here. And one is you can say, I want no part of it. Let someone from the analytics team do it for me. And if you can do that, that is a great spot to be in. I will never knock it. If you can be in that spot, I would say you would want to understand data provenance, which is basically where the data come from, how it's collected, what the individual data points mean. And then you want to understand what can be done with the type of data you're dealing with and what type of output to expect. But then, as with anything, be prepared to justify why you needed the data, why the analysis needed to be done, and why the output is relevant for you as a UXer. The other approach you can take is the one I find myself in, which is, I want to or have to do some or all of it. And so this is where it's worth pursuing some technical skills, particularly around data access and handling. So if I were going to recommend learning any languages and programs as a start, SQL is not that difficult, and you can use it for data access if you are allowed to have direct access to the data. And you can also do some light analysis, like, you can get counts, you can get averages, things like that. For deeper data analysis, Python or R is great. I use both. They have their strengths for certain situations, so that's why I use both. But all of these, Python, R, and SQL, can be learned via edX, Udemy, Coursera, or Udacity. Udacity will offer discounts based on your income level or depending on what country you're from. edX will offer either free classes you can take, or you can pay for a certification. Udemy usually has very steeply discounted courses. Coursera is okay. Coursera, I recommend if there's any particular hands-on projects you want to do. They do have hands-on projects you can follow along with, so I recommend it mostly for that. If you don't want to go down that road of learning Python, R, or SQL, go for advanced Excel skills or basic VBA coding. I don't like advanced Excel, but there are a lot of places where Excel is really the only tool you'll have. And then finally, if you do want to become more technical, learn about data repositories. It's very important to understand how your data is stored and accessed. Then become familiar with common libraries and packages. So for Python, that's things like pandas or polars, NumPy, Matplotlib, Streamlit. R, tidyverse and shiny, in particular tidy principles, which is very fantastic set of principles for structuring your code and structuring your analyses. And then you may want to learn how to bridge between Python and R, because as I've found out seemingly every month, there's something I can't do in Python that has to be done in R, so then I have to bridge between them. You want to learn about algorithms for common analyses. That way, when you're going through and looking at output, if something doesn't seem right, you can kind of backtrack and figure it out. And then, not so technical, but still useful to have, is refresh your knowledge on experimental design, non-parametric statistics, and parametric statistics. And I know LLMs are taboo, but I'm going to stress it because we can't run away from it. We're never going to get away from it at this point, I don't think. Understand the strengths and limitations of LLMs. You would want to learn about things like Ollama, scikit-LLM, scikit-Ollama, LangChain, and DSpy, which are all for Python. There's tidy chat models for R. But be aware that models are geared towards specific tasks, right? So Mistral has a model that is for software engineering, but then if you want to do something like semantic clustering, you can use the Gemini models from Google. And then finally, if you do use LLMs, as always, have a system, have a process for you to review their outputs. You should never, ever let them just go without checking them. You always need to have that human in the loop to verify everything. So that's everything. Thank you. I don't know if we have time for questions.
Yes, we've got 2 questions in the Q&A. Okay. Am I here? Somehow, I'm somehow here. There we go. Hey, we have someone who raised their hand, but that's not going to help you because we don't have the ability right now. Everyone's a viewer, kind of like Zoom webinar. So if you can just write your questions in the Q&A, I'll ask Leslie. The first one that came in says, as overwhelmed designer, How would you describe your role and responsibilities compared to a typical UX research role? You learned Python, which is out of the ordinary for the average UXer. What was your incentive to go the extra mile rather than set a boundary and request resources for it or delegate?
um, so one of the driving factors for that was I knew I wasn't going to get resources. The company when I started, now I'm at the same company and it's gone through mergers, and now I'm at the point where I could actually get resources if I requested them. But at the time, my only resource was Excel. But I also, the second driving force behind this was I looked at the report and I'm like, ugh, this isn't really that insightful. I wanted to do better. And so I challenged myself to do better, and that just kind of put me down the path of learning Python and refreshing my R skills. And from there, that kind of transformed my role to kind of be this borderline UX researcher, data analyst. So hopefully that answered your question.
Cool. We've got 2 more questions. 3. And then in about 10 minutes, we have Kevin, and I would love a little bio break in between. So hopefully we can get through these. Jess also asks, how did you change your workflow or process to review and use research and analytics data to see patterns earlier? Was the problem originally a communication gap or working in silos?
I think it was both of those, actually. So people have a very limited view of UX. I think we've all experienced this, where it's like, if you work in UX, you're the feature factory, you make the pretty screens, and you don't worry about anything else. Well, you don't just make pretty screens. You have to make flows that make sense to people. You have to convey information to people in a way that makes sense. So, it really became me going around the org and, working with people to be like, hey, I know you have this problem. You know what? I can help you solve that problem, but I need this information. But if I get this information, you need to give me at least 2 weeks to analyze it and give you a report and talk through potentially some recommendations for it. So there was a lot of bargaining and making connections I didn't think I'd have to make in order to adapt my workflow to actually do all of this work. So hopefully that helps.
Yeah, thanks. We got 2 more. One is, what is the minimum size of a data set you would deem useful to be able to extract meaningful insights?
So if you're just doing something, like the typical parametric statistics, you could get away with, a sample set of 30. There are people who will argue that t-tests are good all the way down to 5 and 10 participants. I don't necessarily go along with that. I do think, more is better. But if you're looking at the bigger methods like clustering, network analytics, you would start to want to have high 100s into the thousands. And that's not because, with something like only 300 data points, you couldn't do it. You absolutely could still do clustering with 300 data points. It's just that you have to start caveating like, okay, well, I got 4 clusters out of 300 data points. One of those clusters has 60 people in it. This is not really something that we can, build a model off of, but it's something we should still investigate and look into. So it's a little bit squishier, if that makes sense. Yeah, exactly.
Squishy. That's our next presentation. No, I'm kidding. And we've got 1 more question, then we're going to give everybody a short break before Kevin jumps in. Wig says, Rig, love the presentation. I'm actually learning Python at the moment. I don't know if you mentioned this. What frameworks do you use often? Pandas, NumPy?
Yeah. Yeah, Pandas and NumPy are big ones. SciPy stats is probably another one. NetworkX, believe it or not, I will mention it here. So there is something called psychometric network analysis. So basically, if you've got a survey, plug it into NetworkX, and you can understand how, based on correlations, your different questions relate to one another. So that's another big one. Scikit learn is also one where if you want to do things like clustering, if you want to do your regressions, or if you want to just start dabbling in things like neural networks and random forest, things like that, you would want to use scikit-LLM. So those are my big ones.
Okay, great. We're going to have to wrap up for now. Leslie, thank you so much for an excellent
Thank you for
presentation.
having me.
Yeah, thank you for kicking off the Delta CX Hive conference. I'm going to stop the recording for now just so we have recordings all separate. And everybody take a few minutes of a break and we'll get Kevin set up. Thanks.
Bye, everyone.
Thanks.